Good afternoon, and thank you all for joining us. My name is Lindsey Vanderdray. I work in the Office of Planning, Design, and Construction for Smithsonian Facilities as an architect and design manager. I've been part of the National Native American Veterans Memorial Project for almost 2 years now, and I've worked with the project team, memorial designers, and construction team. It's been a pleasure to be part of this project and to help build a memorial to honor the American Indian, Alaskan Native, and Native Hawaiian veterans in Washington, D.C. Today, I'm excited to be speaking with the vendors responsible for designing and doing quality control on the ceremonial flame for the memorial, Image Engineering. The design for the National Native American Veterans Memorial incorporates all the key elements of earth, water, wind, and fire. This was an important part of the memorial designer, Harvey Pratt's initial vision for the memorial, and something we wanted to ensure that was incorporated. At Smithsonian, we successfully worked with 3 of those elements, right? But we've never worked with fire. Our outside architect, Quinn Evans, knew that in order to really pull this off, we needed to bring in a flame specialist. So that's when we brought in Baltimore-based firm Image Engineering. They've worked on flame effects for the NFL, for a variety of rock concerts, and numerous shows on Broadway. And we knew that they would be the right firm to help us integrate numerous safety elements into Harvey's vision. So with that, I'd like to introduce Ian Bottiglieri, Vice President of Design and Project Operations, and Nick Hawk, Director of Installations and Integration at Image Engineering.
Good afternoon, Lindsay. Thank you so much for having us. It's been a complete honor for us to have been able to work on this project so far with you all.
Great. So as I mentioned before, including a flame in our designs is really new territory for Smithsonian. And our concern was really one of safety. So how can we light this flame for special occasions, but ensure that we're being safe for all of our visitors? And especially since this is an outside element. Can you talk a little bit about how you address the reliability and the safety concerns that we had with this element?
Sure. So every project that we work on that includes flames, safety is always the most important piece. It's the first thing that we think about. And there are certain pieces, no matter what the effect is or where it is, that are inherently included in the system from the very beginning, no matter what. And then from there, we look at the environment that it's going to be in, the team who is going to be operating it. So are they skilled expert technicians? Are they folks who get safety training and go through training protocols, but they are not, the expert kind of technicians that we have on our touring shows and things like that. So how do we make a system that is usable and has all of these safety features in it is really the place that we start. And one of the first inherent features that we include is called a positive pilot detection system. And so what that means is that when the operator goes to turn the system on, they arm it, they enable the flame, does the system actually detect that there is a flame? And is it operating within the specification, that the temperature is right and all of that? And if it doesn't, it immediately shuts the system off because it knows that there's something wrong and it's not operating correctly. So that was one of the first systems that we really knew based on this application that we were going to include. And I can let Nick talk a little bit about some of the more specialized systems that we included based on this being outside, in close proximity to water, all of those pieces.
Yes, thank you, Ian. So when you look at this beautiful memorial, you notice that we're outside in a very nice setting. And coming with outside, we have variables such as wind and rain. So we look at all those variables as well, and we incorporate into our system wind detection. So if the wind speed is a little bit too high that day and the operator may not be paying attention or looking for that, the system automatically takes care of it and goes ahead and extinguishes the flame until it's safe to do so. We also took a look at water safety as well, just to make sure that from an electrical standpoint that everything was low voltage. So if something was to break or fail, it would not pose a hazard to anybody that does come to this sacred space.
Great. And I know one of the other big challenges, we have this fairly delicate stainless steel ring that's 12 feet in diameter. The designers really wanted this thing to be very pure and pristine, but they also wanted the flame to be within that. So can you talk a little bit about sort of the tight tolerances of that ring, and how did you incorporate this burn element into that? What were some of the thinking that you had to do moving forward with that?
Sure. So we work very closely with the design, the structural, the engineering teams to really understand how much space in the base of the ring did we have to work with. And then we refined the design over numerous iterations to get every little bit of space that we could down to, an eighth of an inch could make a big difference. And
can I
so,
interrupt for just a second? So
sure.
you actually built mock-ups. You actually built them in your shop and then tested those against the stainless steel and tested the size of those. You didn't just draw them out on paper, right?
Correct. So we started out on paper to see how, theoretically small we could get this and, and provide the effect that the design team had envisioned for it. And then, as you can see on the screen, we put it on our test bench and use the same materials that the ring is going to be made up of, and then experimented with different types of insulation, different spacing, and a couple different variables to one, really figure out what the flame bar would be doing to that metal, and two, ensure that our final solution is one that wouldn't discolor the ring or damage it over time. And Nick can probably expand a little bit on that.
Yes, and the other thing you're looking at is you're looking at this beautifully gorgeous flame. So from the technical side of things, we're making sure everything fits. We're looking at the stainless steel because we know heat is the enemy of discoloration. Once you get a metal too hot, it's permanently discolored, and that's just not acceptable. So we're having various testing points on this model you're looking at, but we're also looking at the flame to make sure from a visual standpoint, does it represent what the end goal for the memorial is? And also what you really can't see from the picture is how does it sound? And that's a huge thing. We want to see the flame, connect with the other elements, but not hear the flame.
Yeah, I think that's something that people don't think about necessarily with flame elements, that there is an audible noise to it. So can you talk a little bit about how you reduce the noise of that flame?
Yes, so the design has a lot to do with how it's plumbed. Fluid dynamics comes into play big with flame systems. Any turbulence that's generated in the pipe can either come out as a harmonic, which will either sound like a whistling, like a very high whistling noise, or it will come out as a low rumble. Neither were really acceptable for this. So based upon what our target was, is we designed the plumbing to have appropriate bends in it, along with things we call flow straighteners. And what the flow straightener does is basically dampen that noise by taking the gas that's coming in and making sure that it's all flowing in the same direction.
Yeah, some of the technical stuff that people wouldn't have thought about that really goes into this. Along those lines, can you talk a little bit about the reliability factor and the maintenance of it? As I mentioned, this is the first time we've ever done a flame element at Smithsonian. So this is really new technology for our technical maintenance staff to have to oversee and work on. So can you talk a little bit about how you designed for the ease of maintenance?
Sure. So ease of maintenance, with anything you have to maintain it. This particular element provides a maintenance-free option, but it still requires a little bit of servicing here and there just to maintain. But there's a variable here. We have this beautiful memorial, we have water. So in order to get to the flame system to maintain it, you have to cross through water. So from the very onset design process, working with the engineering team, we were able to devise a solution with the fountain contractor that one simple switch drains the upper basin and allows the person to work and get to it. When the person does gain access to it, it's as simple as removing two screws and depressing a coupler, and the entire assembly comes out so it can be serviced out of sight. And if there was an issue that needs to be replaced, a new module can be dropped right in with two screws and a coupler, and you're done.
Yeah, I think one thing to mention is that you actually specified that we create 2 of those burn bars, right? That the contractor who's developing this have 2 separate ones, that if one needs some maintenance, it can be taken out and the clean one can just be put back in. So you don't really have any downtime, which is a huge plus for this memorial. So I want to see if we have any questions from our viewers. So we have somebody who asked, what are some safety elements that were built in for the weather? Can you talk a little bit about that? Rain, wind, etc.?
So I think Ian would.
Sure. Yeah, I can start with that. So Nick touched on this earlier, and so wind can prove to be hazardous. And so with flames, there is a dynamic called liftoff, and that's when a wind comes through and it takes the flame and it actually moves it away from the burn bar and may bring it in a direction where we don't want it. And so there are, again, 2 systems that we use to detect for that. The first is positive pilot detection. So it's just making sure that it sees the flame there. It's in the correct temperature tolerances so that we know that we're getting a good solid flame. And the second is the anemometer. So anemometer. So that's the wind meter. And so if the ceremony begins and the winds are calm, the flame can ignite, but as the ceremony goes on, if winds pop up, it gets a little into a hazardous condition, the system will automatically shut itself off when it detects the wind coming through too forcefully that might put the flame into a situation where liftoff happens. And so that wind is one of the biggest issues. Nick, if you want to talk about rain and kind of how that works.
Yes, so rain's another issue that could happen. Our system is designed to operate in up to a moderate rain, not talking a full and downpour, but a nice steady rain. And that is due to how it's constructed. Majority of the materials in this unit are stainless steel. And there's also drainage provisions in the burner bar as well. So as this system is operating and it is raining, there's a way for the water not to stand and basically cover over the burner bar, which would cause the system not to be able to maintain a flame.
Yeah, great. Yeah, we had a couple of questions here about will this flame be an eternal flame? And that's a question I'll answer. That we at Smithsonian decided, again, because this is an outdoor element, that we decided to only light it for special ceremonies or occasions. So it won't be an eternal flame that people are familiar with at John Kennedy's grave, because that one is either able to be fenced off or it's fully attended and guarded. We just don't have that capability at Smithsonian. So we felt like from a safety perspective that it would be preferable to just light it during special occasions. So our special events staff is going to, be able to work with the tribes or whoever's requesting that the flame be lit so that we can schedule those. There's another question here about what safety measures are in use to keep viewers from reaching the flame. And I know that Nick and Ian, you can talk a little bit about things that you use on other projects that you would, like a barrier sensor, and why and how we decided not to include that on this project.
Yes, I'll take this one. So in some of our other installations that may be similar to an eternal flame where there's a flame system that is burning unattended, we use perimeter sensors. That basically it's a light curtain that if you break the light curtain, it says, hey, there's somebody or something inside the safety perimeter, go ahead and shut down. We also use LiDAR as well. It's another means to detect if something or someone is in an area we don't want. However, in this particular installation, we thought that would not lend itself well to the aesthetics of the design. So we leaned more towards a system based upon the fact that there's a big water basin that you would have to climb through to get to the flame, and also that we would have this system always attended. So this system is going to be attended by a member of the museum staff whenever it's in operation, and that member will have a remote control that with one button push, they can turn the flame on and off, as well as there are several emergency call stations around the perimeter that do have the provisions for a general member of the public. If they deem something is unsafe or they feel it's an emergency, they could activate the emergency stop system and shut the flame down as well.
Yeah, great. Somebody asked in the one of the chats about the color. Was there any thought being able to change the color of the flame for special occasions or holidays? You can answer that, but you could also maybe talk about the fact that we had to consider whether to use natural gas or propane, and that color was kind of a factor that went into that decision.
Ian, do you want to take this? Or you?
So I'll let you, you're going to have more of the technical information on this one.
Okay, so I'll take this. We did look at that. That's a very good point. In some of our bigger touring shows, you may have seen, you've seen red flames, green flames, blue flames. Those typically are alcohol-based systems that use chemicals to generate those colors. In this particular instance, we looked at what we had available on site from a cost standpoint as well as a safety standpoint. And we were looking at, there's natural gas already that exists on the property. So we leaned more towards that from a cost standpoint as well as an aesthetic standpoint. The natural gas flame is a much more vibrant flame in our particular application, so we felt that was the correct way to go.
And then we have a last, I'm going to make this the last question, so we'll wrap up here, but someone asked about what about the safety of the monument when not in use for special events? And I'll mention just a couple of safety features that are unrelated to the flame. One is that this is going to be outside, but we will have camera coverage so that our Smithsonian Office of Protection and Security will be able to keep their eye on the space, you know, after hours when there's not a visitor or event activity. We also will have a railing that's going to separate the memorial itself from the wetland, just to, you know, hopefully make sure that nobody falls into the water. That was a big design consideration of the memorial itself. But maybe Ian and Nick, you can just mention the fact that we do have some protection for the burn bar when the flame is turned off.
Sure, so I can field this one. So we have a cover that goes over the opening for the burn bar. And this is really there more kind of what Nick was talking about earlier for a maintenance and longevity. So to protect the burn bar from weather, dirt, any kind of debris that might be able to get in there. But we use this as an opportunity to integrate a safety system. And so the cover plate, if it's not removed from the memorial and placed at the operator station in its holder, the flame would not be able to be ignited. And so what this allows us to do for a few things is one, the flame can never accidentally be turned on with this weather covering on there. Two, it has to be kept in its holder location. And then three, it just ensures that all of the steps are taken and it's properly set up before an operator can turn it on. And at that operator station, there are a couple steps that you need to go through before you can actually turn the flame on. So there is an enable, which makes sure that the systems are ready, the systems are all functioning correctly, you don't have any faults. And then there's a second actual ignition for the system. And to that effect, there are faults and things like that that are also being monitored by some of the building alarm systems and things like that, so the control room can see if there are any faults on the panel that they have in there.
Great, thanks so much. Well, I'm afraid that that's all the questions we have time for today, but I really want to thank Nick and Ian for all their hard work on this project, and for, you know, the time and the dedication that they've put into this project. We couldn't have done this without you, I don't think. So thank you so much. Do you want to say anything in closing about you know, working on this project? And
I'm excited to actually see the product. As many people know, it is being built right now. So we're getting excited because everything that we've done, all the research and planning for, we're actually now getting to see in real life, which is always the best part of these type of projects.
Yeah, we're very fortunate that we get to work on a lot of the largest stages around the world, whether it be a concert touring stage, an NFL field. We have some other permanent installations other places, but to have helped design and create something that's going to live with the Smithsonian on the National Mall is really special for us, and something that everybody here, from Nick's team to my team, are taking pride that we're going to have a hand in that.
Great. Well, thank you again so much to everyone who joined us today. Thanks again to Ian and Nick, and everybody have a wonderful day.